we are going to draw the redundant we're going to solve for this one because we want to find this right here. Okay, so we'll just draw this again right here. Okay, so we have this, then it's A, B, C, and we got C, Y over here, and A, Y over here. So we have CX over here, and then we got EX over here. Okay. So to find the CX force, we will have to use virtual work. Virtual work means we just assume that the CX is equals to 1. So we will just put this value as 1 right here. So this means that this 2 will become 1. Okay. And then after that, we are going to find the AY and CY for this redundant CX reapplied. So to find that, we do the exact same thing as we do here to find the CY and the AY, but for this one. So to find that, same thing, we just do total moments at C equals to 0, and then we got here, right, for the AX, and then minus AY 6 equals to 0. This one is for this force right here, this moment right here, and then this one is for this moment right here, equals to 0. So solving this, we get AY equals to 0.5, and then we are going to find the CY now. Same thing as primary structure. We do this. So AY plus CY equals to 0. So we found that this CY equals to negative 0.5 after substituting this. So CY is negative 0.5. So again, we're just gonna do the same thing as the primary structure. We have to cut this right here, 1, 1, 2, 2. Okay, so let's solve for the case 1, 1. So here we got the cut, right? And then we got this is a A, 0.5 here, and then this is a x1 distance, and then I'm gonna assume this to be M1 for this structure. So we will do this to find the M1, right? So it's negative 0.5 x1 because it's in the clockwise direction, so it's negative. So then we have M1 equals to 0. So M1 equals to 0.5 x1. So for the case 2, 2, we got cut right here. We assume this is M2. So we have 0.5 coming down, negative. This is C. So we have CX. We assume it's 1 using virtual work. So we do the same thing. Sorry, my phone had just died. Okay, so let's continue. So we do the same thing as we do here, and we do for the primary structure. So M2 plus oh yeah, this is a distance x2. Okay, so we times that by 1, this point, so equals to 0. So we got M2 equals to, this is x2. Okay, so then we are gonna find the delta C. I'm gonna find the delta C that we've been looking for using this formula right here. So this formula right here. Okay, so we got 6, 0 for our this for A and B. So the length of that is 6 meters, and then the small m indicates the m that is located at this structure. So we have 2 structures, 3 including actual beam. So redundant CX applied, we got the small m, small m1, small m2. And for primary structure, we got a big M1, a capital letter M1 and capital letter M2. So same, we just substitute that to this formula. So this is a small m from the redundant structure, small m, and then the big, the capital letter M from our primary structure. So let's do that for both AB and BC beam frame. So we got the small m first, which is this one, A to B. We got a small m, a 0.5 x1. So 0.5 x1 times the capital letter M. Capital letter M we got from the primary structure. So we got a capital letter M, this right here. So let's substitute this to this. So it is negative 30 x1 squared plus 157.5 x1. Okay, so we're gonna x, and we're not finished yet. We're gonna do for both M1 and M2. So plus 3, 0, because the distance from B to C is 3. Okay, so we're gonna take the capital letter M2 and the small letter M2. Okay, so then we're gonna do for BC. So we got the small m from the redundant applied, small m, and so it goes to x2. So let's choose x2, and then from the primary structure we got m2 equals to negative 15 x2 squared. So then after resolving this, we actually got become 506. Okay, so I just resolved this using a calculator, and then we are gonna find the unit load, FCC. So the formula for unit load is small m squared over EI dx. Okay, so we're gonna again do for both. So for the AB, we got 6 meters long, and then for that, so this is the moment for the redundant CX applied, the small m. Okay, so first we're gonna do for the case 1 on AB, which is 6 meters. So m1 is equal to 0.5 x1. So it's just 0.5 x1 square it, and then you wanna add it with from B to C, 3 meters, and this is the formula, is the equation. So we got x2 squared over EI dx. And then solving that again using a calculator, I got 1 over EI 27. Okay, so looking at our compatibility equation, we got this. So we are just going to substitute that. I'll just write down here. Delta C equals to delta C plus CX FCC equals to 0. So delta C is this one, and it's 1 over EI 506.25. You want to find CX. So after solving this, we got CX is 18.75 kilonewton. So our question asks us